Welcome to the second video in our series on solving simultaneous equations using algebra. In this video, we're going to talk about substitution, which is the alternative method to elimination. Some students find this a little bit more difficult than elimination. However, you do need to learn it because this method is what helps you solve two equations when they're not necessarily straight lines. The method is going to be the same. All right, let's follow the steps. Label equations as 1 and 2. It's familiar. Transpose one of the equations until x or y is by itself. Basically, we have to solve one of these for x or y. Now, it doesn't matter which one you pick, but it's best to pick the one that looks the easiest because you're less likely to make mistakes. Number 1 looks pretty easy to me, so I'm going to pick number 1. And I'm going to solve for x. Solve 1 for x. And again, it doesn't matter if you solve for x or y. You just have to flip what you do later. It's all about which one looks easier. All right, x plus y equals 6. Solving for x. X equals 6 minus y because we're subtracting y from both sides. This is called transposing. Okay. This is our solution. Now, we're going to substitute this into the other equation. Has to be the other one. That's very, very important. So we're going to sub x equals 6 minus y into 2. So 2 is 2x plus 4y equals 20. So now it's going to be 2, but instead of x, we're going to write 6 minus y, because that's what we found x to be. Plus 4y equals 20. Nice. Solve for the unknown. Notice now that this is an equation only in terms of y, which means we can solve for y. Let's do it. We'll need to expand this out using our claw method. 12 minus 2y plus 4y equals 20. These two are unchanged. Bit of cleanup. Negative 2y plus 4y. 12 plus 2y equals 20. Get rid of the 12. Subtract 12 from both sides. 2y equals 8. Divide through by 2. Y equals 4. If you've watched the previous video, you'll know that we're on the right track. Now, sub solution back into original. In this case, it doesn't matter which one you sub it into. So we're going to sub it into 1, because that looks nice and easy. Sub y equals 4 into 1. X plus, not y, but 4 equals 6. Run out of space. X equals 2. As before. And of course you might want to do a check, but if you want to check that these are the correct answers, you can check the last video where I did that. Okay, let's try a more difficult example. Okay, here's my second example. I've picked this one from the textbook. Looks a little bit more intimidating, but it's actually really not that bad, as you'll see. Let's do it. Label equations as 1 and 2. All right, 1, 2. Transpose one of the equations until x or y is by itself. Now, if you look at this, here in equation 2, y is already by itself. And there's a lot of questions in the exercise that have sort of already done this step for you. But I've included it there because it's important to know. All right, so we don't need to do it. We're just going to use this y. Okay, substitute this into the other equation. So as you can see, this is going to replace that y. Okay, so sub 2 into 1. Let's do it. 2x plus 3, not y, but 4x minus 15 on 5 equals 13. Solve for the unknown. You can see this equation is just in terms of x. Just a little bit of algebra until we figure out what x is. Let's do it. 2x plus, now how does this 3 distribute across, well, 3 multiplies here and here. Why is that? It's because 3 is 3 over 1, and when you multiply fractions by fractions, it's top times top and bottom times bottom. So really, this 5 is just going to be multiplied by a 1, which is kind of like the hidden denominator there. Okay, so 12x minus 3 times 15 is 45. Equals 13. All right. How do we deal with this now? Okay. When you say things like this, and you've got to divide it by 5 here, the easiest way to get rid of it is to multiply everything through by 5. Because if we times this by 5, that's going to cancel this denominator here. But to make it legit, you have to multiply everything by 5. Okay? So 10x plus 12x minus 45, because this denominator is cancelled, equals 13 times 5. Oh gosh, what's 13 times 5? 65, I believe. Okay. 10x plus 12x is 22x. Minus 45 equals 65. And we add, we add 45 to both sides, which gives us 110, I believe. And x equals 110 on 22. What does that equal? Well, I'll tell you. I've seen the answer already. It equals 5. I didn't know that off the top of my head. I checked the answer beforehand. 22 times 5 is 110, so it makes sense. Okay, x equals 5. There's a nice little bit of algebra there. Okay, and we're going to substitute this back into the original. I think it would be easiest to probably actually sub it back into this second one, because we're not going to have to do any algebra once we've done our subbing in. So we're going to continue up here. we are going to sub x equals 5 into equation 2 to end up with y equals 4 times 5 minus 15 on 5. Okay, 4 times 5 is 20. Maybe you can see the solution already. 20 minus 15 is 5. Oh, look at that. 1. Which is also correct. Because like I said, I checked the answer beforehand. We can do our check, of course. This one is already checking equation 2, right? Because, yeah, we just did it. We subbed in 5 and we got 1. So that's our check for there. It's the best we can do. But we can check equation 1 to see if it's good. So we'll check equation 1. And we're going to say 2 times, not x, but 5 plus 3 times 1 equals 13. Does it? Yes. 10, 3, 13. Bang. True. Very happy. All right. Thank you for watching. Have a nice day.